Okay, so hello and welcome to this video tutorial for E411, Statics and Dynamics of Simple Mechanisms. So we have this problem here. It states the 10 kilo block is subjected to the forces shown. In each case, determine its velocity when t equals 2 seconds if the velocity is equal to 0 when t is equal to 0. Okay, let's start with the problem on the left then. It's kind of drawn a free body diagram for us already. We can we could apply this idea of Microsoft man, this idea of a normal force being there to counteract the vertical component of this 500 Newton force, but really we're only really concerned with the horizontal direction in which this box is traveling, right? So let's consider the sum of the forces in the x direction. Well, things acting to the right it only includes the horizontal component of this 500 Newton force. So that would be 4/5 of this 500 Newton force, 400 newtons, minus things acting to the left, and we've only got here this 300 Newton force. So we can say then that the resultant force in the horizontal direction, the horizontal dimension really is 100 newtons. Okay, we can also now introduce this idea that the sum of the forces acting on an object is equivalent to its mass times its acceleration. Okay, since we know that the sum of the forces acting in the horizontal here is 100 newtons to the right, we can therefore say that 100, i.e. the sum of the forces, is equal to the mass of the object, which is 10 kilos, times its acceleration. Therefore, acceleration equals 100 divided by 10, which is 10 meters per second squared. Okay, so now we've got its acceleration. We want to determine its velocity at time t equals 2. Hopefully it's evident to you guys intuitively that the velocity at time t equals 2 is equivalent to 20 meters per second here. Understanding that it's accelerating from rest at 10 meters per second squared for 2 seconds. Okay, it's going to reach 20 meters per second at time t equals 2. Okay, let's underline that and move on then. So we've got this second problem here where there's this horizontal force acting at 20t newtons. Okay, so the force here is a function of time, which is interesting. Looking at this, we understand then that we introduced this same idea of the resultant force in the horizontal direction, but here we're describing it in terms of t. So we can say the sum of the forces in the x is equal to 20t, which is equal to ma, which we covered earlier. Therefore, we can say that 20t is equal to 10a. Therefore, 2t equals a. Okay, so we have acceleration as a function of time now. We have acceleration as a function of time, but we're wanting to determine the velocity as a function of time, right? How we can do this is we can describe acceleration as a time derivative, which looks like this. We can say that acceleration is the equivalent of the rate of change of velocity with respect to time. Okay, which that's just the definition of acceleration, right? And since we've introduced this derivative here, we now have a differential equation. How do we solve differential equations? Well, one way is to integrate, right? So we have this dv over dt is equal to 2t. We can integrate both sides with respect to t. Let's just give myself a little bit more room here. Still need a bit more room. So notationally, this integration looks like this. So I'm integrating my left-hand side with respect to t, and I'm integrating my right-hand side with respect to t. So what I'm doing to one side, I'm doing to the other. This term, if you're unfamiliar with integration, I'd suggest carrying out your own learning outside of this video to understand what's going on here. But if you are familiar with integration, you'll understand that this integrates to this, and you'll understand that this integrates to this. In terms of this plus c, it states in the problem that when the velocity at time t equals 0 is equal to 0. So I can imagine substituting 0 and 0 in for v and t, and we'll find that c is equal to 0. Okay, so I could just remove my c. So I now know that v is equal to t squared. Therefore, v at t equals 2 seconds is equal to 2 squared, which is 4. Okay.